if we have our geometric figures, if they're congruent, that means they have the exact same size and shape. You also know what congruent is. Woohoo. And then with congruency, this part down here, those two sentences, if you have two congruent figures, all the parts in one figure are congruent to the corresponding parts of the other figure. So all the corresponding sides and corresponding angles are congruent. Why that is important? We're about to see a little acronym for reasoning that you use throughout proofs when we talk about triangle congruencies and proofs. But also, this part of what I was highlighting, it's really important for today. We're talking about congruent triangles. The order matters. So you writing AC instead of CA would be wrong. So even for a segment, so depending on how you write it, it's going to be really important for the order. We also have something, it is CPCTC, is on your paper. Okay. So this is an acronym. 100% I guarantee you just telling me what CPCTC stands for, it will be on a test or a quiz. It'll be just like the question is, what does CPCTC stand for? And you write it out. What it stands for. Congruent parts oh wait. Nope. Corresponding parts. There we go. I know, I'm so neat. Corresponding parts of congruent triangles are congruent. Congruent parts of corresponding triangles are congruent.
You mean corresponding parts?
Corresponding parts of congruent triangles are congruent. There we go. Corresponding parts of congruent triangles are congruent. This is going to come into play when we do proofs. We have triangle proofs. For the triangle proofs, we're going to have things like you prove triangles are congruent based off of like side angle side, or angle side angle, or like the different ways we're going to side by side. We're going to do that next week. But then if you're trying to prove that some other part is congruent, that's where this is going to come into play. It is used often. Memorize this phrase. Corresponding parts of congruent triangles are congruent. Memorize it. 100% it will be on a test or a quiz. Okay. So on to this part. So we're going to be writing congruency statements or just like statements about congruency all day today. A congruency statement is something like this. Saying that triangle ABC is congruent to triangle FED. Now, if you notice this one, it has all of the markings and each vertex is color-coded. So that's where we're kind of seeing like A corresponds with F, B corresponds with E, and C corresponds with D. So if you wrote the triangle as triangle ABC for that first part of the congruency statement, you have to write it as triangle FED for the second part. Now, if you write it differently to start, so if you write it as triangle BCA, that's fine. It's just that when you write the other part, you have to make sure you're using the corresponding sides or like vertices whenever you're writing that new triangle, that corresponding triangle. So based off of this, our corresponding angles, angle A would be congruent to angle F. Angle B is congruent to angle E. And angle C is congruent to angle D. There are two ways to know the corresponding angles. You can use the picture when there's a picture, but also from a congruency statement, since it has to be written in that order, you don't need the picture to be able to write those corresponding angles. You could use straight from like the signs or like Whatever's first in the list has to be corresponding, second has to be corresponding, and third has to be corresponding. So when it comes to the corresponding sides, if we do it without the picture, so AB would have to be congruent to FB, because first two. Another side, we have BC, it would have to be congruent to segment EB, and then AC is congruent to FD. Notice I put that little line on top of each of those because when we're talking about congruent segments, you need the line above it. And we're just saying that it equals like 4, that's when you don't have to have the line above it. You feel okay? All right. It's really just detail, like just making sure you're paying attention to detail. So, looking at that first one, we have beam supporting a fence, they're congruent triangles. This is our congruency statement. The triangle ABC is congruent to triangle DEF. So which of the congruency statements is correct? So we have all these different options, A, B, C, and D. Which one correctly corresponds with our either angles or sides? So I'll give y'all a minute to look at it. Did y'all use the statement from the paragraph, or did you use the picture?
I don't even know the picture.
Okay, use both. Yeah, it's up to you. If it is the picture, so something I always do when it comes to pictures, if they give me the congruency statement, I go through and mark it. So A and D correspond, B and E would be congruent, and then C. So I did those little markings on every picture that is involving all this congruency stuff, if I'm able to. That way it just helps. Like I'm a visual person. Like I like to see those little markings whenever it comes to pictures. Okay. So then on this bottom part, A has all the markings for us, and this is considered an easy one. The reason this is considered easy, the pictures themselves are copy paste. Like they're the exact same thing. It didn't rotate. It didn't like do anything. Y and M, X and N, like all the letters, like nothing's out of place. So writing your congruency statement of X, Y, Z, you can go in that same order. If it was X, Y, Z, then N, M, N, or P. And we're done. That would be considered an easy one because it's like nothing has changed. The one underneath it, a little bit harder. Still not too bad because all it did was just kind of rotate one part of it. So if we have triangle, let's say NLK, what would the other triangle have to be? Yep. Again, you could write the first triangle however you want. It's the second one that you just have to make sure it's all corresponding. So that's something like when we go through and check stuff and I have y'all do something on your own and I write an answer on the board or something, if you have it differently, just make sure like your order matches my order in terms of what's corresponding. Okay. So on that next part, for that example, it gives you the congruency statement, and then there's no marking, so I'm going to go through and mark it. So X, Y, Z, and then M, N, L. That way it's already marked. It helps me for keeping things kind of organized. If you don't need to, then don't do it. But it's just something, it's helpful to do it. So if we're talking about the measurement of angle Y, Y and N are corresponding, so 124. Part B, the measure of angle M. M and X are corresponding, which makes M 33. On C, X or YX, what is the segment that corresponds with YX? And M, and since this one doesn't have a line above it, it has an equal sign, we need the actual number that's labeled, which is 8. The one below it has the congruency statement. So that means this one below it, we write just what the segment is, which would be correct. And L. Put that line, little line above it. And then switching up the congruency statement, writing it as N or L N M Z Y X. Are we okay? Okay. Fun part, this is our only non-triangle of the day. Everything else is going to be triangle based. So we know that A, B, C, D, so A, B, C, and D goes with F, G, H, K. We're solving for X and Y. What's the easy one to start with?
3x minus 6 equals 9.
Yep. 3x minus 6 equals 9. So that's 3x equals 15, so x equals 5. So then, yeah, using that, that makes this 20 plus 2y. We plugged in that 5 for x. So then 20 plus 2y equals 44. So then 2y equals 24 and y is 12. Yes? Good? Questions? Nope. Okay. So then I want y'all to do these two problems. All right. Ready to move on? Next part. We really only have one theorem today. We have another page that's gonna have a little bit of vocabulary, but not really. So we only have one theorem for the day, which is the third angle theorem, and this is specifically for our triangle, and it's kind of piggybacking off of our triangle sum theorem from yesterday. So if you have two angles that are congruent, you don't know the triangles are congruent. All you know is that two angles are congruent. Then automatically that third angle has to also be congruent. How come?
Because they're all added up to 180.
Right, they all have to add up to 180. So if these numbers are specifically like whatever the two are, that missing number has to add up to 180. So it's kind of piggybacking, kind of like a corollary, but to our angle sum from yesterday, but not really. This is specifically just talking about the angles themselves. This does not work for sides. This does not work for their sides. It is just for the angles themselves. We'll talk about why, but mainly it's because two sides doesn't mean the third side is the same. Right? Two sides of a triangle doesn't mean the third side. But two angles means the third angle. Okay. Done with theorems for the day. There are 3 problems on this page. I want you to answer all 3. Okay, are you good with the first one for 36? What about the second one being 75? Are we okay with that? Yes? Okay. What's the answer for the third one? 105 is correct. How did you get to it?
I think I'm going for all of them, and then I looked at them.
Yeah, so you know this has to be 35, which means this has to be 110. This is 70. So what does this one have to be?
70.
This one also has to be 70.
Yeah, that's 105.
And right, it's asking for this full angle, let's combine them together. That's where the 105 is coming from. So you kind of have to piece through a few of them to get to that final answer. What you could have also done, did anyone, my guess is no, since we talked about it, but do y'all see that there's a triangle here, right? So if you just knew that this one was 40, this was 35, then default, that third angle has to be 105. So what's going to be tricky with these pictures is that, like, there's a bunch of triangles inside of one picture. This one has, what, 1, 2, 3, 4, 5 triangles? Is that right? Yeah.
I mean, you only see 3, but.
Right. But, like, you don't think about those larger triangles. Did y'all ever see those pictures where it's like how many squares are in the picture? That's kind of what this turns into sometimes. Like, there are so many different triangles that trying to see or like trying to make use of what is the most efficient way or the most helpful, that like you might be stuck on a problem one time, but like it's just because you're not seeing that there's a triangle somewhere. Something like that. Okay, so I want y'all to solve these ones.
I got X equals 5, Y equals 6.
Yeah.
I think I'm a second.
Okay. How did you get those two answers? You did a system, so you said 6x minus y equals 28, and then 4x plus y equals 22. And then you did it, those cancel, so 10x equals 40. 50. Okay. And that's where the 5 came from. Then once you had one symbol into the other one. Okay, wonderful. What about the second one? So if I write it as, so something that is helpful if you are not comfortable with them layering. So it's this triangle. And then the other triangle is this one. So something, if you're not comfortable, if you draw, I know that I can like move things, but if you draw it off to the side, so this one has your line here, it was H, this was L and M, and then if you look at the other one, oh, we didn't have to look at each other. There we go. This one is J, G, and M. So if you draw them out to the side, instead, sometimes it makes it just like a little bit easier if you're uncomfortable with the overlapping part. If you don't mind the overlapping part, then okay. So if we have triangle, let's go with triangle MHL. So if I wrote triangle MHL, what would have to be the other one? M, G, J. Correct. G, J. On this one, if we have triangle H and L, and that's my first triangle. G and J. Good. Again, if you want to write it like out to the side and redraw them so they're separate, kind of helpful hint. Definitely, unless you're like, if you're totally uncomfortable with it, do it off to the side. But then once you start seeing the pictures a lot more, you might start getting better at seeing it overlapping. Okay, we're almost in the home stretch. We do have properties for congruent triangles, so we still have reflexive, symmetric, and transitive. Where these are going to come into play, you are going to see reflexive actually get used. So, where it's going to get used will be problems like this, where we have a proof and one of the angles is used in both, and it's like a corresponding where it's the same, it's that corresponding part of both angles. If we are trying to prove a triangle is congruent, we're going to learn like angle, side, angle, side, angle, side, angle, side, like all of those things. You would have to state an angle congruency part in there, so sometimes it will be that reflexive property of saying that like angle M is congruent to angle M. So it is going to come into play finally, where it doesn't just seem like why we know that. So those are different properties of congruent triangles. We will use those later on, but it's the same ones that you know before, like reflexive, symmetric, and transitive. And on to our last little bit of today, which is some congruency statements. So if we look at A, I'm going to show y'all like little tips that just at least help me. Actually, y'all try it first and then see if you're successful, see if you can figure out your own way of how to do it, and then I'll show y'all my little trick. Okay. A and U. And then anytime you have a segment congruency statement, it's telling you that T and B are also corresponding. So you should have triangle MUB. Good. Okay. So same thing, A and E are corresponding. And then when they give you that segment congruency, it's saying angle C and T are corresponding. So let's say I put it as, well, what one of y'all put? CAT, okay. So if you have CAT, that is 2, 1, nothing. So 2, 1, nothing, and the other would be T, B, C. Okay? It really is just detail, like just kind of like analyzing pictures. Okay, so